Okay, boys and girls, so today is Friday, and we are working on lesson 10-2, where we are multiplying fractions again. This time we are multiplying a fraction by a whole number. So again, multiplying a fraction by a whole number, we are working on pages 389 through 391 today in this video. So if you do not have your Volume 2 math book, please pause the video and go get that now. Let's take a look at the first example. How much tomato juice is needed for a group of 4 people if each person gets 1/3 cup of juice? So I have a group of 4, and I know that each person, each being a key word there, that tells me I'm either going to multiply or divide, and they get 1/3 cup of juice. To me, that kind of sounds like 4 groups of 1/3 or 4 multiplied by 1/3. Let's read the second part of this question. How much tomato juice is needed if they each get 2/3 cup of juice? So again, each is the key word. Now they've just kind of changed it, like a what if. So we technically have one problem here, and then we have a second problem here, as in what if we change it and now they get a little bit more. So I'm going to zoom out. And it says that you can solve these problems any way you choose. So first, we are going to use repeated addition. Just like in a regular multiplication problem, I can take 1/3 and I can add that 4 times because I know that I have 4 people. When I do that addition, I know my background knowledge on adding fractions tells me that the denominator is going to remain the same. We're still working with thirds. We're going to add the numerator. So 1, 2, 3, and 4. So we have a total of 4/3 cups. We know that when we're talking about an amount here, we should change that to a mixed number. Right now, it's a fraction greater than 1, meaning our numerator is bigger than our denominator. So we know that 3/3 would equal 1 whole, and then we have 1 more left over. So this would actually be 1 and 1/3 cup. So that's how much juice would be needed for 4 people. But now we have the second part, 2/3 cup. Well, that would be the same as adding 2/3 plus 2/3 plus 2/3 plus 2/3. Again, denominator does not change. We add the numerator. 2, 4, 6, 8. 8/3. Again, we should probably change that to a mixed number. So we want to think, how many times will 3 go into the number 8 without going over? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So I can get 2 whole groups, and that would be like taking away 6, and that would leave me with 2/3 remaining. So 2/3 cups. Now, here's the thing. Right now, I don't see any multiplication here. I don't see any multiplication equations. All we've used is repeated addition. But again, it said solve any way you choose. So I guess this answer is technically correct, but what would that look like as a multiplication problem? So again, this was number 1, and this was question number 2. So if we were going to write this as a multiplication equation, we might say, well, I know that this is a unit fraction, 1/3, and I can multiply by the number of groups. And I have 1, 2, 3, 4 of them, right? Group of 4. So that multiplication equation for question number 1 would look like 4 whole groups multiplied by 1/3. Now, I'm going to show you guys a trick. I'm really not supposed to show you this, but when you're multiplying and you have a whole number multiplied by a fraction, what you really do is you change it and you put the whole number over 1, and then you multiply by the fraction. And you just go straight across. 4 times 1 is 4, and 1 multiplied by 3 is 3, for a total of 4/3. Guess what? Same thing you got up here. So now think for a moment, how would you write a multiplication equation for question number 2? If you have someone next to you right now at home, you can turn and talk or think to yourself. I'm going to give you guys just a moment. So for question number 2, we're going to come right down here and look at this. We know that we had still 4 people, right? A group of 4. 1, 2, 3, 4. So we still have that whole number 4. This time we're multiplying by 2/3. And again, Mrs. Body just taught you a trick. You just put this whole number over 1 and then multiply straight across. 4 times 2 is 8, and 3 multiplied by 1 is 3. Still arriving at the same answer of 8/3, which we know changes to the mixed number 2 and 2/3. Let's try maybe 2 more. We're going to kind of simplify these just a little bit. Dory lives 1/4 mile from the school. If she walks to and from school each day, to and from, how far does Dory walk during a school week? So a school week is like Monday through Friday. We know in 4th grade they like to throw those little pieces in there. So let's look. They gave us a chart, and it looks like to school on Monday, from school on Monday. To school, from school, to school, from school, all the way through Friday. So if we look, how many days do we have? 1, 2, 3, 4, 5. But then the from school would be the distance. So we have to include that as 6, 7, 8, 9, 10. So really we have 10 groups multiplied by 1/4, meaning she's going to walk 1/4 of a mile, and she's going to do that 10 different times. She's going to do it to school on Monday and then from school. So that's 2 times. So throughout the entire week, it's a total of 10. Again, we're going to simplify this because Mrs. Body just likes to simplify things. We're going to put it over 1 and multiply straight across. 10 times 1 is 10. 1 times 4 is 4. Now we need to change this back to a mixed number. We're going to think, how many times can 4 go into the number 10? Well, I know that 4 times 2 is 8. So that'd be like taking away a group of 8. So we have 2 wholes, and then 10 minus 8 is 2/4. So 2 and 2/4. And then what are we measuring, though? Is it time, days, distance? The question is, how far does Dory walk? So it'd be 2 and 2/4 miles. Okay, let's look at a couple that look a little more like what you're going to do today. And draw a picture to explain how to find 3 times 2/5. Well, if you have 2/5, it's kind of like giving that fraction piece 2/5, and you have 3 of them. Right? In your brain, you're thinking, okay, I have like, obviously, others, but I'm focused on just 1, 2, 3. 3 times 2/5. You could even break that apart even more if you wanted, understanding that 2/5 is really just 1/5 and 1/5, right? So each of these could be broken into their unit fractions of 1/5 and 1/5. I think most of you probably drew a 2/5 and you drew 3 groups, and that's fine. So if we were to multiply 3 times 2/5, that would be like putting the 3 over 1, multiplying across. 3 times 2 is 6, and 1 times 5 is 5. And again, we can see that, 2, 4, 6, 6/5. We arrive at the same answer. Let's look at 2 more. So when we look at these tend to confuse students a little bit, and you're going to see some kind of like that in your work today. So we want to make sure we're paying attention to these last 2. I know this video is a little bit longer. You have to write and solve a multiplication equation for what you see illustrated here. So when we look at this picture, I see 2 groups, right? Kind of like the whole number 2, like 2 pizzas or pies or whatever these are. But then I need to look and see what fraction of the pie is being represented. So there's 1, 2. So 2 is my numerator. And then what's my denominator? How many pieces were there total? 1, 2, 3, 4, 5, 6. 2 multiplied by 2/6. So now I need to solve. That's the same as saying 2 over 1 times 2/6. 2 times 2 is 4. I'm going to write the answer up here. And 6 times 1 is 6. So I have a total of 4, 6. Let's try this one. On a number line, this is a little tricky. I see here, it looks like 4 groups. That's just visually what I see. Here's 1, 2, 3, 4. Hopefully you can see the same thing. So that's the whole number 4. And then what is it that we're multiplying by? Well, it looks like it went up 2/3. So 4 multiplied by 2/3. And then if we were to solve, that would be 8/3. And we can turn that back into a mixed number. When we do, we should arrive at 2 2/3 if we did this correctly. 3 goes into 8 2 times, right? That would be like taking away 6. 8 minus 6 leaves us with 2/3 remaining. So again, writing an equation for what you see represented. Today you are going to do problems 4 through 7. So you have 4 problems here. And then on the back, you have some word problems. 8 through 12. You do have an exit ticket. It's actually these 2 questions right here. So if you want to do that on paper first, and we'll meet at 2 o'clock to go over these questions. Let me know if you have any questions about today's work.